Welcome to the third week of this course. So far, we have studied about the data collection process and the different types of variables. And depending upon that, we saw different summary measures. So today, we are going to learn about different visualizing tools for categorical and numerical variables. So we will begin with the categorical variables, where we will learn about bar chart and pie chart. Then, in order to study the relationship between two categorical variables, we will use the stacked bar chart. Next, for numerical variables, we will learn about dot plot, histogram, box plot. For two numerical variables, we will have a scatter plot. And if you have a numerical and one categorical variable, there we will learn how to draw side-by-side box plot. So, let us begin with the visualization of categorical data. And the first one in this category is your bar chart. So, bar chart is basically used to display categorical data and compare values across different categories. If you consider the first example from your week 2, where you were interested to determine the favorite pizza topping of your friends and you collected the data there, okay, and the counts were like this. So toppings was your categorical variable and it had categories as pepperoni, mushrooms, olives and onions, and the corresponding counts came out to be this. Now if you want to make a bar chart based on this data set, then how you make it is in this way. So on the x-axis, you will mark pepperoni, mushrooms, olives and onions, and here on the y side, you will mark the counts, okay, and you will draw a bar at each category and the size of the bar is corresponding to the number of counts. So you can see that for pepperoni, it is 4, the count was 4, whereas for mushrooms and olives, it was 2. So the height of the bar over here is still 2 only. And last, onions, it is 1. Now, instead of representing it in count, if you can recall, we had another summary measure for categorical variables, that was your proportion. So for finding the proportion, what we do is that we divide the count over here for each category by the total number of data points. So in this case, if you look at pepperoni, the count is 4 and the total number of individuals that we had is 9. So we divide for this, the proportion will be 4 by 9, 2 by 9, 2 by 9 and 1 by 9. So if you need to draw this, then it will look like, so here, so instead of count on this side, you have the proportions. And the height of the bars now go up till the proportion, okay. So here you can see that it goes up till here 0.44 and here it is going up till 0.22 and likewise for this. So bar charts are very simple to draw and they are very easy. You just have to look at whether you want to draw it with respect to the count or with respect to the proportion, and simple bars will give you enough idea. And by just looking at these bars, you can get an idea that pepperoni has the highest proportion in that data set, whereas onions has the least representation. The next chart that is commonly used is your pie chart. Pie chart is basically a circular chart that is divided into categories and the size of each category is proportional to the quantity it represents. For instance, if you consider the same example of these pizza toppings and you want to make a pie chart based on that, so it will look like this. So if you see, you have pepperoni as 45%, mushrooms and olives are 22% because the count here was 2. So when you express it in percentages, you will get 22% and for onions it is 11%. Now if you look at the size of these segments, okay, or the categories, it is varying. So for pepperoni, it is the largest segment. Why? Because the count for pepperoni or the percentage is 45%, which is the highest. So you can see that the size of each category over here is proportional to the quantity it is representing. Now, one more thing is that here, if you have more number of categories, suppose you do not have just these 4 categories for the pizza toppings, instead you add some more here, suppose 5-6 additional toppings you add, and then you collect the data from your friends, then what you obtain is a chart looking like this. So here, if you see, pepperoni goes down to 17%, sausage is also 17%. If you look at pineapple, mushrooms, olives, these all are 8%. Onions and tomatoes are 4%. Now, if you just look at this pie chart over here, if you look their areas, right, 17% is this one and this is 13%, but you cannot distinguish that clearly. Similarly, if you have too many categories over here, it becomes difficult to interpret and make a distinction between them. Also, unlike bar chart where you get to see the exact count corresponding to each category, you do not do any such thing in pie chart. So these are expressed in percentages, and if it is not even given to you, then if you just look at this pie chart over here, you cannot understand what is the correct representation. So that is why we do not prefer pie chart whenever we have large number of categories. Okay, so we will learn it through Python how to draw it at the end of this week. We will see how to draw pie chart or how to draw a bar chart for different data sets. Now, for one categorical variable, you can draw a bar chart or a pie chart. And you have also seen what are the drawbacks or the positive points of both the charts. Now, suppose you have 2 categorical variables. In that case, you want to study the relationship between those 2 categorical variables. Then, before drawing that chart, we need a contingency table. Contingency table is basically used to study the relationship between the 2 categorical variables. Okay, so it basically displays the frequency distribution of these variables, or you can say that it reflects what combinations occur how many number of times. For instance, if you want to draw a contingency table of gender and beverage preference, then gender also is a categorical variable with categories as males and females, and for beverage preference also you can have the categories as coffee and tea. So on this side, if you see, the first column over here is for gender and the 2 rows over here correspond to males and females. Next, you have the beverage preference on top. In the columns, you have these coffee and tea. And then within this, you have the counts corresponding to each combination. At the bottom, where you have written the total, so total corresponds to basically, this is the column total because 30 plus 25 will give you 55. This is 45, and these are referred to as your row totals because if you add 30 and 20, you get 50. Likewise, here also, this is the row total and 100 is the total number of individuals. So, if you want to interpret this, you can look at this value which is 30. So, this shows that there are 30 males who prefer coffee, whereas there are only 20 males who prefer tea out of this data set. And the total count, we know that total number of males are 50 and females are also same. Whereas if you look in this side, what is happening is coffee is preferred by more number of individuals as compared to tea. So if you look at this one, so 25, so basically 25 corresponds to the females who prefer coffee, or you can also see that out of the total individuals who prefer coffee, 25 are female. So you can make different inferences based upon the contingency table. So basically you need to have 2 categorical variables which have categories. One you will mark in the rows, the other one will take the columns, and then you will write the count for each category as it is from your data set. You add those values and then you can make different interpretations as we are doing in this case. Similarly, you can consider another example of occupation and car preference. So occupation again is a categorical variable with categories as engineer, teacher and doctor, and car preference includes sedan, SUV and hatchback. Now, suppose you have the data set and you want to make the contingency table based upon that. So you can see from here these values within this table, these represents the counts or the frequencies corresponding to each combination. And likewise, you have these as the column totals. So 45 is the total number. Out of all the individuals, that is 95, 45 prefer sedan, irrespective of the occupation. 45 is the sedan. For 30 individuals prefer SUV and 20 prefer hatchback. Likewise, in this data set of 95, 35 are engineers, 30 are teachers, and again 30 are the doctors. If you want to make an interpretation, you can just look at the first count over here, that is 20. So 20 over here means that there are 20 engineers who prefer sedan, whereas there are only 10 engineers who prefer SUV and the least number is for the hatchback. Next, if you look for the teachers, then 15 teachers prefer sedan and 15 doctors prefer SUV. So hatchback cars, if you see from here, it is the maximum representation is by the teachers. So there are 10 teachers who prefer hatchback, whereas engineers and doctors prefer less. So obviously this is just a sample data set. The actual values might differ. Now, these are the counts. Instead of just writing the counts, sometimes it becomes easier if you have the observations in terms of the percentage. If you want to do that, you can express each of these counts over here in terms of the percentage, either in terms of the based on the total, or you can base it on the column totals or your row totals. So suppose if you make percentage comparison based on your row totals, then the table that you had is going to look like this. So instead of the counts, you now have the percentages for each category. Now, if you want to do the percentage comparison based on row total, what you have done over here is 20 is divided by the row total, corresponding row total, that is 35, and you multiply by 100, which is approximately 57%. Similarly, for teacher, you have divided it by the corresponding row total, and each category over here is divided by 30 and multiplied by 100. Fine. Similarly, in this case also we have done it. Now, if you want to understand what does this represent, so basically it shows that approximately 57% of the engineers prefer sedan. So by just looking at the percentage, it becomes more interpretable, because you know that okay, 57% are preferring sedan, whereas 50% of the teachers prefer sedan and only 33% of the doctors prefer it. Likewise, if you see over here, doctors usually prefer SUVs and teachers prefer the hatchback cars. So this is based on your row total. Likewise, you can have it based on your column total also. So in that case, you will divide each of these values or the counts, that is 20, by 45 into 100. And then you will get the corresponding percentages. Each value in this column would be divided by 45. For this SUVs, the counts will be divided by 30 and then multiplied by 100, and same way we will divide by 20 and multiply by 100. And you will get the column totals. And obviously you can make it in terms of the overall total also. So you will divide and multiply by this. So 95 is the total number of individuals. So you divide by 95 and then multiply by 100. So this is what you get. So out of the total number of individuals from whom the data has been taken, 21% of the engineers prefer sedan. And out of all those who prefer sedan, that is 47%, out of this percentage, 21% are the engineers. Likewise, from the SUV, if you see, the maximum percentage corresponds to the doctors, and for this hatchback, the maximum percentage is by the teachers. So you can make different comparisons based upon the contingency table. Now, once you have the contingency table, it becomes easier to draw a stacked bar chart, which is used to display a pair of categorical variables. So, on this side, you will have one category, that is the profession, engineer, teacher and doctor. And on this side, you have the number of individuals. So, as you can see, these are actually the bar charts, but they are stacked one above the other in order to make comparisons more easily. Now, if you look at the engineer one, here sedan is represented by the blue color, SUV green color is used, and the red color is used for hatchback. By just looking at these areas, you can immediately interpret that, okay, so for engineers, since this blue portion is the largest for engineers, it means that sedans are usually preferred by engineers, and that is what we have already concluded in the previous slides. Similarly, if you look at this green portion that corresponds to SUVs, then we can also see that doctors prefer SUV more as compared to the hatchback or the other professionals. Similarly, for hatchback, if you see red color, so this hatchback is preferred more by the teachers. So by just looking at this chart, you can get an idea. Now, if you look at the heights, as we have done in earlier slide also, that for bar chart, the height of the bar will go up till the corresponding count. So here also, for engineers, the first bar is going till 20 because we had 20 sedans, 20 engineers who preferred sedan, and then you had 10 engineers who preferred your SUVs. So it will go from 20 to 30, and then it will go from 30 to 35, only 5 are there, because 5 preferred the hatchback. Likewise, for this also you can make comparison. And if you look all across these categories, you can identify that how many engineers prefer different types of cars, likewise for different professions as well. So stack bar chart basically gives you an easy interpretation when you have two categorical variables and you want to investigate the relationship between them. So what are the three main categorical charts that we have seen? So for one categorical variables, we can use the bar chart and the pie chart, and for two categorical variables, we can use the stacked bar chart, and for which we may need your contingency table. So this was all about your categorical variables, and we will see how to draw them in Python. Next, we move on to the numerical data set. So when we want to visualize the numerical data sets, we can use the three charts. The first one is your dot plot, then we can make a histogram and also a box plot. So we will first see these three for a single numerical variable, and then we will move on to the scatter plot, which is used to understand the relationship between two numerical variables, as we have done for categorical variables. So first we saw for a single categorical variable, and then we also investigated about when you are given two categorical variables. Likewise, we will do for your numerical data sets also. So the first one in this category is your dot plot. See, dot plot basically displays individual data points as dots along a single axis to show their positions and frequency. So if you have ages of a group of people and you want to draw a dot plot, then what you do over here is that on x-axis you just mark the different ages, and on this side y-axis basically are the counts, but you can often skip this part, you don't need it, because by just looking at the dots you can identify it. And we keep on stacking the dots one above the other if we get more number of individuals corresponding to 25, suppose. So suppose if there are 5 individuals who are of age 25, then we will make 5 dots one above the other. Next, if you find 4 observations corresponding to age 30, then you will make 4 dots. Likewise, we will keep on moving and we will make a single dot for 60 if there is only a single individual. So it is easy to draw, okay, and you just have to keep on adding the dots and the counts can be easily seen from here. It is the simplest plot that we use, or the simplest visualizing tool that is used for the numerical variables. But the drawback for this dot plot is that it becomes difficult to interpret when you have a larger data set, because you cannot keep on adding points over here one above the other if the data size increases. And in that case, the dot plot becomes very much cluttered and it becomes difficult to make interpretations based upon it. So in order to rectify this, one can make a histogram where instead of marking the exact data points as dots, we categorize them into different class intervals or the bins. And then we see in each bin how many points are falling. So let us see that. So histogram is basically used when we have more number of data points, and it divides the data into bins or intervals and counts the number of data points that fall into each bin. So if you consider the same example of ages, but you add some more ages in this, suppose now you have a data for the ages of 30 individuals or something maybe more than that also, then what you do over here is, if you want to draw a histogram in this case, then first of all, we need to organize the data into bins. Okay, so here if you see, there are 30 individuals. The smallest observation over here is 25 and the largest over here is 60. So first of all, we find the range, so that is 35, and suppose you want 8 bins, so bin width basically comes out as range divided by the total number of bins that you want. That is approximately 4.5. Okay, so we can just make it 4.5 or take some approximate number. Now, based upon this, we are going to group the data points. So, the first bin is going to start from 25 because 25 is the data point that we have in our data set. So, you start from 25 and go up till 29.5 because bin width is 4.5 for each interval. So, the next will start from 29.5 and go up till 34. We'll start again from 34 to 38.5 and likewise it will go. You can also start from 24.5 and then take 5 gaps. Okay, so if you want this, you can approximate this as 5 and then also you can divide these class intervals into bins of size 5 and go ahead. So here we have categorized them based upon 4.5. So if you count the frequency, count frequency means that you will count the number of data points in each bin or the class interval. So what we find over here is that 8 data points, there are 8 individuals whose age falls between this interval. Next, you have 6 individuals whose age is in between 29.5 to 34, and likewise we can see it will go on. So in total, there are 30 individuals. Now, if you want to create the histogram based upon this, so what we do over here is, on the x-axis, we will mark the ages. Okay, on the y-axis, we will mark the frequencies. And we will start, so here if you see 27.25, this is basically the midpoint of the first interval. So here, all these are the midpoints of each class interval, and the height of these bars over here goes up till the count, corresponding count. So this class interval had 8 frequency, so its height is going till 8. Next class had 6 observations. You can see, then 5, then you had 2 of 3 frequency, next 2, and finally you have only 1 observation coming from the last class interval. So this is how you create your histogram. So if you want to make it by hand, this is the process. If you want to make it just by using some software, that is the Python, so we will teach you how to do it in the end of this week. Sometimes you see that you may have to compare different histograms. And if you just have these frequencies over here, then it becomes difficult to compare different histograms in terms of the frequencies. Rather, it would be better if you have it in terms of the relative frequency, then the comparison would make more sense. For instance, in the same example, these are the class intervals, this was the frequency, and if you want to calculate the relative frequency, what you do is you divide individual frequencies by the total number, that is 30. So 8 by 30 corresponds to 0.27. Likewise, 6 by 30 will give you 0.20, and you will move on. And if you add up all these frequencies, you will get relative frequencies, you will get 1, because the sum would be 1. Okay. Now, instead of making the histogram in terms of frequency, you can make it in terms of relative frequency. So, your y-axis would be replaced by the relative frequencies, as you can see over here. So, in this case, you see it is going from 0 to 0.3, because the highest observation over here corresponds to, if you see here, it is up till 0.27 only. So, that is why it is showing you till 0.30 only. Rather, you could make it up till 1 also. From 0 to 1 it will vary, and then you can see the size of these bars over here. So, once you have expressed it in terms of the relative frequency, you can now compare different histograms. Suppose you have this group of ages, this is group 1. You can have a data set corresponding to a different group of individuals, that is suppose group 2, and then you make their histograms. So if you make it in terms of relative frequencies, then it would be more appropriate. Now, histograms have an additional thing, because by just looking at the histogram, you can identify the shape of the distribution. For instance, in this case, if you see and recall from the summary measures that the skewness, if you talk about the skewness, it is right skewed, because it has a long right tail. And it also has a single mode. This is the peak at which it is occurring. So the maximum mode means that it has the maximum number of points at this interval. And that is true, because we have seen that it has 8 individuals in this particular category. So mode is over here. So it is unimodal, and it is your right skewed. So you can have left skewed likewise, or symmetric. Also, you can have different modalities also. So if the shape of your histogram is something like the one that you have just drawn, you can see from here, it is going in this way. So it is unimodal and it is right skewed. Instead, it might be left skewed also. So in that case, what will happen? The shape of your histogram would be something like this. When you divide the data set into different bins and then draw the histogram, it would look something like this. So in this case, it is again unimodal, but it is your left skewed, right? And this, if you can recall, this right skewness can happen if you have the salaries of employees in an organization. So there will be certain individuals who have higher salaries. So that is why it will pull the mean towards the higher end. Likewise, this can be the retirement age of employees. So then you get left skewed data sets, and you can obviously have a symmetric one. So which basically is like this. As we know, it corresponds to the heights of the individuals. So you can have something like this. So it is symmetric, right? It is going in this way. Okay, so this corresponds to the height of the individuals. It is unimodal but symmetric. So just looking at the histogram, you can get an idea about the skewness or the shape of the distribution, which can either be your left skewed, right skewed, or symmetric. One more thing that you can get or interpret from here is about the mode. In all these cases, you had a single mode. Peak is occurring at this point. Here, the peak is occurring at this and this, right? So mode basically corresponds to that value which occurs the maximum number of times. So here in this example that we were just looking, you can recall that it has the highest number of individuals in this category. So that is why mode is high. Now, instead of unimodal, you can have a histogram such that it looks like this. Somewhat here, and then it goes below and then restarts. So what is happening in this case? You had a single data set, but now you have two peaks over here. It means it is bimodal. If you have, suppose you collect the data of the salaries of people living in a locality, then you might have two modes, because one may correspond to low income earners and the other may correspond to high income earners. So in that case, you will have a bimodal histogram. Now, also note that bar chart and histograms look similar. But the difference is that bar charts are drawn for categorical variables, whereas histograms are used for your numerical variables. Also, if you see in the bar chart, the x-axis is not a number line. On this side, it is a number line, and the order of the bars is not interchangeable in case of your histograms. Because here, if you see, you cannot bring the class interval that corresponds to 8 individuals before, take it to replace it with the category of 40 to 45. That is not possible, because the number of individuals that you have in each category is already fixed. So if you interchange the bars, then the shape of the histogram would vary.